Alright, we're doing presentation for telecommunication project number 2, the FM modulation and demodulation. And my group consists of me, Joosuk and my partner Kisan. So this project is about for us to build a demodulator circuit, and with this circuit we will conduct multiple testing such as SNR testing, data transmission testing, and we will use a FSK FM transmitter, which is given to us by the professor, and this is the Elenco radio kit, and we will use input frequency of 10.7 megahertz. Okay, so I will talk about the theory behind our project, and to talk about first, I will talk about the modulation. There are many different types of modulation, such as amplitude modulation, frequency modulation, but we will use the frequency modulation for this project. And the frequency modulation is basically a method where you're packaging this information into a carrier wave, and we do this by varying a frequency. And as you can see here in the equations, this is before the modulation. You can see this is the instantaneous frequency, and after the modulation, you can see the message has been already packaged. Next, I will talk about the demodulation. Basically, we're building a demodulator, so this is the main part of our project. And the theory behind demodulation is basically taking the packaged data that we modulated, and we are going to depackage it and get the information from the package. So demodulator basically is a circuit that does this depackaging, and there are many different methods to do FM demodulation, such as quadrature detector, PLL, Foster-Seeley discriminator, and a ratio detector. The method we chose was PLL, which stands for phase locked loop, and this method consists of three main parts: phase comparator, low pass filter, and voltage controlled oscillator. And basically what it does is the phase comparator compares the phase of the input signal with the input signal phase and the signal derived from the output oscillator. And after comparing, it will match the frequency of its oscillator and the frequency that is outputting. And as you can see here, the feedback loop takes the output, and then it will feed it back into the comparator input, so we can match the phase that it was outputting. And now I'll pass it over to Kisan, and he will talk about our project of the project.
So for the method we are using is phase lock loop. So we have chosen the HCD4046 as our IC for the demodulation process. The reason we choose this IC is because of the low power consumption. It has excellent PCO frequency linearity, minimal frequency drift, and zero voltage offset due to an OPM buffering. And we have the choice of three comparators with this IC, which are exclusive OR, Edge trigger JK flip-flop, and Edge trigger RS flip-flop. For our project, we are using the comparator 1, which is exclusive OR. And the center frequency for this chip is up to 17 megahertz, which is preferable for this project, since our input frequency is going to be 10.7 megahertz. And the power supply ranges from 3 to 6 volt. Our circuit is based on the schematic provided over here. As you can see, pin 14 is the signal input which will be coming in from the Elenco radio kit. The phase comparator output is pin 2, with which is the exclusive OR gate that we are using, and this is the phase comparator output goes to the low pass filter and then is fed into the voltage control oscillation, and the demodulation output is from the pin 10. And the table here shows the values that we are using to build our circuit for different components, resistors, R1, R2, C1, C2, as you can see over here in the picture. And the cutoff frequency for our low pass filter, which is right here, is 15 kilohertz, and the voltage control oscillation is 2494 kilohertz. And this is our test result from the lab. We used the oscilloscope as our input. Our input frequency was set to 10.7 megahertz, and with the modulated frequency of 10 kilohertz, and amplitude was set to 1.2 volt peak to peak, as you can see over here. And the input sinusoidal wave with the 10.7 megahertz. This is our output from the low pass filter. It is saying that the output has 166 kilohertz output. So that's the end of our project and demonstration. Thanks for watching.